Hi students, this is T. Balakrishna, Chemistry Lecture, GPT KOTHAGUDEM. Today our topic is corrosion part 4. Subtopic is rusting of iron. Mechanism of rusting of iron. Before going to discuss about the rusting of iron, first we know the electrochemical theory of corrosion. In this electrochemical theory of corrosion, when the metal is exposed to the environment, metal is act as an anode, environment is act as a cathode. So in this metal is act as anode. That means oxidation reaction takes place at anode. So metal is converted into metal ion by losing of electron. Losing of electrons is called oxidation. So the electrons are transferred from anodic part to cathodic part through the conducting medium. That electrons are gained by active agents which are present in the environment like H2 and O2. That gained electrons is converted into 2OH minus. So we are gaining of electrons, so that is reduction reaction takes place cathodic part. In some cases, the environment not contain water component. Only oxygen is participating in chemical reaction. The oxygen is gained the electron which are came from the metal that gain that electron is converted into oxide ion. Next, the metal ion formed at the anodic part, non-metal ion formed at the cathodic part, combine to each other to form the corresponding products like when the if it is react with oxide only to produce metal oxide, if it is react with hydroxide to produce metal hydroxide. That means metal is converted into metal oxide or metal hydroxide. That is the principle of this theory, electrochemical theory. So depending upon this theory, we can easily explain the mechanism of rusting of iron, because rusting of iron is one of the example for the corrosion. So in this corrosion, when the iron is exposed to the environment, they form natural galvanic cell between the iron and environment. In this cell, iron is act as anode and environment is act as a cathode, because iron is highly reactive than environment. So which is a highly reactive, that is act as anode, which is less reactive, that is act as a cathode. So iron is act as a anode. So here iron is act as anode. So if the iron is act as anode, oxidation reaction takes place at anode. So iron is converted into Fe plus through by Fe plus 3 by releasing of 3 electrons. So that means iron is converted into ferric ion. So these electrons are transferred from anodic part to cathodic part to the conducting medium, and they reaches to the cathode. Here they gain the electrons, water molecule and O2 which are present in the environment, gain the electron which are coming from the iron. It is converted into hydroxide ion. Next step is the ferric ion formed at the anodic part and hydroxide ion formed at the cathodic part combined to each other, they produce ferric hydroxide. So here electron gaining reaction takes place at cathodic part. Next, the combined reaction is combination reaction is takes place plus Fe plus 3 plus 3OH minus giving rise to FeOH taken thrice. So that is called ferric hydroxide. This ferric hydroxide gradually lose the water. The ferric hydroxide lose water gradually and convert into the brownish rust. So that is 2 FeOH taken thrice giving rise to Fe2O3 plus XH2O plus 3 minus 6 H2O. So this is a mechanism of rusting of iron. That means iron is converted into reddish brown color ferric oxide. Ferric oxide. The ferric oxide molecular formula is Fe2O3 XH2O. This is gradually lose the water molecule. It is converted into Fe2O3. Fe2O3 shows brownish rust color. This is a mechanism. Thank you, student. This is T. Balakrishna, Chemistry Lecture, GPT Kothagudem. Thank you very much.